CloudFormation. So without wasting any more time, let's move on to today's agenda. So we'll start today's session by discussing why CloudFormation is actually needed in the first place. Once we're done with that, we'll move on to the what of what is CloudFormation actually. After that, we'll be discussing what things are needed to get started in the CloudFormation service. Now, among those things, you have a JSON document. So we'll be learning how to create a JSON document. So before that, we'll be seeing the structure of a JSON document. Once we learn the structure, we'll see how a JSON document actually looks like. So we'll see how a sample JSON document looks. And in the end, we'll be doing a demonstration. So in the demonstration, we'll be doing two demos. The first one will be a really simple one, and the other one will be a little advanced. Let's move on to the first topic, that is why AWS CloudFormation. So why do we need CloudFormation? So for example, you have an application. Now most of you guys know that and we have done this in the previous sessions as well, that we created an application, right? Now that application is actually dependent on a lot of AWS resources. Now if we were to deploy and manage all these resources separately, it will take up a lot of time of yours, right? So to reduce that time or to manage all these resources, what if I told you have a service? Yes, you got that right. So you have a service called AWS CloudFormation. So using AWS CloudFormation, you can manage and create and provision all these resources at a single place. Now, this is what CloudFormation does. But now, what is CloudFormation exactly? So a CloudFormation is basically a service which helps you model and set up your AWS resources so that you can spend more time on your application rather than setting up and provisioning these resources, right? So basically it's a tool using which you can create your applications quickly. Also, you can create templates in AWS CloudFormation. Now, how do you create templates? Basically, you would be using the CloudFormation designer. You'd be putting in all the resources that are needed. You would be defining the dependencies of these resources, and then you'll be saving this design as a template, right? Now, what will you do with this template? This template can be used to create as many copies as you want, right? Say, for example, you have a use case wherein you want your application in multiple regions for backup purposes, right? So if you want that, you won't be implementing or you won't be creating each and every resource one by one in each of the regions. What you can do is you will create it at one place in CloudFormation, have that template in your hand and deploy that template in the other regions as well, right? So what will this do? So first of all, your replication will be very precise, right? So there won't be any changes in the copies that you have made. Second of all, you'll be doing that quickly because you don't have to do the process all over again. You just have to click a button and that template will be provisioned or will be launched in that region. So this is what AWS CloudFormation is all about. It makes your life simpler by handling all the creation and the provisioning part, right? So this is what is AWS CloudFormation. Now, how do we get started in CloudFormation? Since it's a very useful service, how can you as a user use this service? So let's move on. So for using the CloudFormation service, first of all, you need a JSON script. Now, why do you need a JSON script? Because you'd be creating a template, right, in the CloudFormation designer. You'd be using the drag and drop option and filling in the AWS resources, right? Now, when you'll be doing that in the backend, it'll actually be creating a JSON script. Now, what you can do as a user is if you're good in JSON, you can create your own JSON script. Otherwise, you can use the CloudFormation designer to create a template. Now, for creating a template, like I said, you need a JSON script. Now, what is a JSON script then? So a JSON script is basically a JavaScript object notation file, which is an open standard format. That means it is human readable. So you can read it as well as the computer. So if you don't need the programming knowledge for this, what you as a user would be doing is you would be designing your template in the CloudFormation designer, and that will automatically create a JSON script. You can do it the other side as well. Like I said, you can create your own JSON script and feed it in the CloudFormation designer. So this is how CloudFormation works. This is how you'll be using AWS CloudFormation. But then how can you learn the JSON script? So it's very easy. So basically you have to follow a structure in the JSON document. What is this structure? So that structure is like this. You'll be creating the following fields. So the first field will be the AWS template format version. So this will basically contain version of your template. Next up is a description. So description is a text only file or is a text only field wherein you'll be describing your template in words, right? So if I'm a user and I want to know what your JSON does, without reading your JSON script from beginning to end, I can read the description in simple English and understand what your JSON script will do, right? Then you have the metadata. So metadata will basically contain the properties of your template. Then you have the parameters. So any values that you have to pass to the template will be included in the parameters. Next comes mappings. So mappings would basically include the dependencies between your AWS resources. Then comes conditions. So conditions are basically the conditions that you'll be giving to your template when the stack will be created or while the stack is upgraded. So if your stack is being created or your stack is being updated, these conditions will be looked onto. Then comes outputs. So whatever outputs your template will provide or your creation or stack will provide will come in the outputs header. Then you have the resources field. So resources field will basically include all the AWS resources that you want to include in your infrastructure, right? Now, if you look carefully, you actually will be only dealing with the resources part, right? Because you will just be populating in the resources and creating the dependencies, right? So basically you'd be populating the resources part and that is what it was all about, the resources part, right? Now, this is theory. Now, how does a JSON document actually look like, right? A JSON document looks something like this. So like I said, you'd be working on the resources field, right? So you'd be including the resources field and in that say so this JSON document is all about, if you had noticed, it's about S3, right? So you are basically including an S3 bucket and in the type you'd be specifying the type of service that will be including this bucket, right? Like in this example, a JSON document doesn't know what service you're talking about. So you'd specify the name of the bucket and inside the braces you'll be specifying which service. So over here you'll be specifying the S3 service. Don't worry, I'll be showing you guys this JSON document in a moment. But before that, you should understand how a JSON document is structured, and this is what we're doing right now. Now guys, this is the CloudFormation dashboard. Now you have to create a stack over here, right? And for the creation of a stack, you require a template. So first we'll design a template and then we'll create a stack. So this is my CloudFormation designer. Let's go back to our slide and see what we actually have to do. So this is our first demonstration. Herein we'll be creating a S3 bucket from CloudFormation. So we'll be designing a template around that for first, and then we'll be deploying this code, right? So let's do that. So let's go to our CloudFormation window now. So we have to create a S3 bucket. So we'll scroll down to the S3 service. So here is the S3 service. We'll click on the S3 service. We'll click on bucket and drag it over here, right? So this is our S3 bucket, guys. Now you can edit the name of the template over here. You can name it as Edureka CF. That means Edureka CloudFormation, right? So you specified that. Now this is your JSON code. Now you can compare the JSON code, guys. Let me make it a little bigger for you guys. Yeah, so this is the JSON code, guys. Now I didn't code this JSON script, right? I just dragged and dropped this bucket over here in CloudFormation and it automatically generated the script. Comparing it with the code that we have in our presentation, let's see. So we have resources. Yes, we have resources. We have the name of your bucket part. So basically this is the name of your bucket. And then it's a type wherein you'll be specifying the S3 service. So you have type and you're specifying the S3 service over here. Alright, so if you want to change the name of the bucket, we can do that over here. Let's specify it as Edureka CF. Alright, so we are done. This is it, guys. This is all you have to do. So now for running this in CloudFormation, all you have to do is click on this icon, create stack. Now this will lead me to this page, which is the create stack page. Now it has automatically uploaded this template to the S3 bucket and it has specified the URL here, right? You'll click on next. You'll specify the stack names. Let's specify it as Edureka CF. Right, so you don't have to specify anything here. Let's click on next. Click on create. So you'll be seeing the events on this page. Let's refresh this. So it says create in progress, right? So my template is now being created into a stack. and that stack will have the AWS resource in it, which is the S3 bucket, right? So I think the time is enough. Let's refresh it and check if our stack has been created. So it's still in the creation phase. Let's wait. All right. So now it shows me that the create is complete. All right, guys. So let's go to our S3 service and check whether we have that bucket that our AWS CloudFormation created for us. So we'll go to the S3 service. And here it is, guys. So this is the bucket that we created. All right. So you can see the time, it's March 28th, 2017. Today is March 28th, 2017, and the time is 7:05 and the time is 7:07 here. All right. So this bucket has just been created by CloudFormation. So guys, like I said, it is very easy. It is easy to understand and to deploy as well. You basically just have to create a template, and that is it. AWS CloudFormation will do the rest for you. And the cool part is that you can replicate that template as many times as you want, right? So it will save you the time. Okay, this demonstration is done. So we have created an S3 bucket using CloudFormation. Let's see what our second demonstration is all about. So now we'll be creating an EC2 instance in which we'll be deploying the LAMP stack, which means in that EC2 instance, you'll be installing Linux, you'll be installing Apache, you'll be installing MySQL, and you'll be installing PHP as well, right? So let's see how will we do that. So for our second demonstration, we will again go back to the CloudFormation console. We'll click on create stack. Now we have to launch a LAMP stack. So a LAMP stack is basically a sample template in AWS, right? So we can select the sample template and we'll click on view or edit template in designer. So a LAMP stack is basically an EC2 instance with Linux, Apache, MySQL and PHP installed onto it, right? You can see in the designer that you have only specified an EC2 instance and you've attached a security group to it. So you need the security group obviously because you have to connect to this EC2 instance, right? Now a LAMP stack is basically a web server, remember? Now let's see the template for this LAMP stack. So we discussed the structure of a JSON document, if you guys remember. So the first part was the AWS template format version, then you have description, then you have parameters. So parameters, if you guys remember, it is basically the values that you'll be passing to the template, right? Now, if you're creating a LAMP stack, you'll be needing the database name, you'd be needing the database password, you'd be needing a lot of things, right? If you're installing MySQL, you'd be needing the username, you'd be needing the password. So all of that you can feed in here in the parameters. So you can specify the key name. So if you are connecting to the EC2 instance through SSH connection, you'd be needing a key pair, right? So you'll be specifying the key pair here. Then you'll be specifying the DB name and the other details. Now how will that look when you'll be creating a stack? So let's do that. We'll click on this icon which will now create a stack automatically. So you'll be prompted on this page, click on next. Then you will reach this page wherein you are feeding the entry, right? So you would specify the stack name. So this is by default. So stack name, so we'll be specifying the stack name first. So let us stack name be LAMP demo. And then we move on to the parameters part. So whatever you specified in the JSON parameters field will be reflected over here. So we specified DB name over here. So it is asking me for the DB name. So let's give it as Edureka and let's give the DB password as something. Can DB2 password, DB user as Edureka. Instance type as T1.micro. Why T1.micro? Because if you guys noticed in the template, we didn't specify a virtual private cloud. That is a VPC. Now all the instances which are launched these days, of which all the new instances which are there in EC2 are to be by default launched in a VPC. But since we are creating a JSON file and we didn't specify a VPC, you have to select an older version of your EC2 instance. So let it be T1. So T1 is an older version. It runs without a VPC as well. And then you have to specify a key name. The key name would basically be used to create a SSH connection to your instance, right? So our key pair was edureka_a. We'll select that and we'll click on next. Now SSH location is basically your IP address if you want to specify. I don't want to specify it, so we'll click on next. You don't have to enter anything over here. Click on next, confirm and click on create. now is happening in the background is it is picking up that JSON file and is creating a stack for us. Launch an EC2 instance. It will then install Linux onto that. It will then install Apache, MySQL, and then in the end, a PHP installation. So what we will do, once it says that the creation is completed, we will go and check if everything has been installed on our server by creating an SSH connection, right? So let's wait until this stack is complete. Alright guys, so as you can see in the events that the creation is now complete. So let's check that if our installation has been correct. We'll go to the EC2 instance. Now this is our instance which has just been created. We can check that it's been created on March 28th, right? So today is 28th. Alright. So now let's connect to this instance. So for that, we'll have to copy the IP address. This is the PuTTY software. For those of you who don't know how to connect to EC2, you'll be pasting your IP address here, right? And then you have this private file, right? So this is of the PEM extension. But the PuTTY software needs a PPK extension. So you have to convert this PEM file to PPK. That can be done using the PuTTYgen software. So this is the PuTTYgen software. So I'll be dragging this file here. Okay, it doesn't work. So we'll click on load, go to downloads, click on all files, select my PEM file, click on open, click on OK, and then click on save private key. So let's name it as edureka underscore A, click on save. So my file has been saved. We'll close it, go back to our PuTTY software. You have entered the IP address here. You'll click on SSH, click on authentication, click on browse, go to your PPK file, click on open, and click on open here. So now you'll be connected to your SSH, through your SSH to your EC2 instance. So any Linux installation on your AWS infrastructure, the login will be ec2-user. Alright, so you're in. Let's see if we can connect to our MySQL installation. So MySQL-edge, so it is on localhost -p port number 306, and then the user that we gave was edureka and the password was this. Okay guys, so we are in. So that means we successfully created the edureka username which we specified in the JSON script. That works well. And then you specified, okay, we also specified that we need a database, right? So let's see if it is showing our databases or our databases have been created as well. Okay, so it has a database called edureka, right? So the JSON script worked well. Now the thing here to notice is that how granularly you can configure your JSON file, right? First of all, it launched an EC2 instance, then it installed Linux, then it installed MySQL, it configured its settings, and inside MySQL it gave you a database, right? So this is awesome guys. So this gives you the whole control of AWS just through JSON script, right? And this is the power of CloudFormation. Now if you want this infrastructure or whatever you have created right now to be replicated again to some other instance, that can be done with a single click of a button, right? And it is actually pretty awesome because if you were to install this LAMP stack on a server or on AWS, again, if you launch a EC2 instance with a Linux OS, installing Apache, MySQL, and PHP may take time. It actually takes time because you have to open the console, you have to open the terminal, you have to enter the commands, and depending on your internet speed, you will install all those packages. So this is neat. It does everything for you automatically, right? So guys, this is what CloudFormation was all about. So I'll close this session. Let me go back to my slide. All right. So guys, we are done with the LAMP stack demo. Today's session is going to be on autoscaling and load balancer. So today I'm going to tell you how you can autoscale your resources so that they become highly available. And this is what we are going to do today. All right, so with that guys, let's start with today's session with the agenda for today. So guys, this is what we are going to do today. First, we're going to see what are snapshots and AMIs. So these are basically the entities using which you will be auto scaling your resources. So once you know what are snapshots and AMIs, we'll move on to why do we actually need auto scaling and what is auto scaling exactly. After that, we're going to see what is a load balancer, and towards the end, we'll be doing a hands-on, which is going to be very interesting because I don't think there's a demo out there which can show you the kind of demo that I'm going to show you today. All right. And if you think about it, guys, if you're thinking about moving to the cloud industry, auto scaling and load balancing are the very important topics in this in this domain, right? So you should know about them. So if you don't know about them, please pay attention today because you're going to gain a lot of knowledge today. All right, moving on, guys. Let's start with the first topic, which is snapshots and AMIs. So let us see what are those. So I guess most of you are aware of what an EC2 instance is. So for those of you who are not, an EC2 instance is just like a raw server. It's a fresh piece of computer that you have just bought. It's just like that, right? So on that computer, you can choose any operating system that you want. So once you have the operating system, you can install any kind of software on it. All right, so you have to install every time you launch a new an EC2 instance, you have to install all the required softwares on it. All right, but there's a workaround. What if you want a specific configuration of EC2 instance? Say you want 5 EC2 servers which are exactly like this, like each other, right? So one way of doing that would be to launch a new instance every time, install the required packages every time, and going about it, right? The other way of doing it would be to actually create an image of once you will be configuring your EC2 instance, and after that you'll be creating an image of your EC2 instance, and then using that image you can actually deploy 4 more EC2 servers. All right, so this image is basically what is an AMI. So AMI, which is an Amazon machine image, is nothing but an executable image of your already existing EC2 instance, right? But before an AMI can be created, there's a thing called snapshot. Now, what are snapshots? Snapshots are nothing but the copy of the data, the copy of the data that you have on your hard drive. So basically, if you have your C drive, right, and you want to copy your C drive, you copy your C drive onto some external drive, so that becomes a snapshot. But if you can boot from that external drive so that to your whole operating system comes up on some other machine, then it becomes an AMI. So this is basically the difference between the two. A snapshot is not a bootable copy, an AMI is a bootable copy that you have. All right, so I hope you got the difference between what is an AMI and what is a snapshot. So I'll repeat it again, and you use an AMI to basically replicate an EC2 instance again, so that you don't have to do the configurations all over again. Right, so now you'd be wondering, we were to talk about what is auto scaling, what is load balancing, why do we need AMIs? But be patient, you'll be clear with everything with the session. All right, moving on, guys, let's now discuss why do we need auto scaling. Now before that, guys, now the way I'll be going through this session is I'll be explaining you each topic and then I'll show you it in the AWS console. All right. So we just discussed what are snapshots and what are AMIs. So let me quickly show you how you can configure or how you can create an AMI of an already existing EC2 instance in the AWS console. So give me a second. Give me a second. I'll just go to my browser and my AWS console. So guys, this is my AWS console. I hope it's visible to you. So the first thing that you'll be doing is you'll be going on to your EC2 console. All right, so in your EC2 console, you will have all your servers that are running right now. Right, so for the sake of simplicity, I've already deployed 2 servers, which are server 1 and server 2. Now I have configured them both with Apache so that they can they can host a website, right? So let me quickly show you how the website actually looks like. So if I'll go to this particular IP address of server 1, this is in path server 1. Right, so this is how the website looks like. Right, similarly for my server 2, if I go into my server 2, this is how my server 2 will look like. Here it is. Alright, so these are my two servers. Now what I want is I will create an exact copy of these servers so that they can be replicated. Alright, so when I say replicated, everything from softwares to this website will be copied onto an image, and that copy or that image, when I will deploy it, it will be deployed inside one more EC2 server in which I don't have to do anything. This website will be there. I just have to go to the IP address and I can see this website. Alright, so now what I'll be doing is I'll be creating an AMI of both these servers. So let's create an AMI for server 1 first. I'll select the server 1, I'll go to actions, I'll go to image, I'll click on create image, and all I have to do is give an image name for it. So let me give the name as live server 1. Right, this is my image name. I'll click on create image, and that is it. It takes in your request for creating an AMI and it does that. Right, pretty simple. Now similarly, I'll be doing it for server 2 as well. I'll select server 2. I'll go to image, I'll create an image, and I'll name the image, say, live server 2. So once I've done that, you can see the images in your AMI tab. So if you look at over here in the images section, you can look at AMIs. If you go to your AMIs, you can see there are two images which are just being created, which are in the pending state as of now, and they are live server 1 and live server 2. Now using these images, you can create any kind of server that you can create the exact same server with just a click of a button. Alright, you don't have to configure anything much. Alright, so this is how you create an AMI. Pretty straightforward, guys. Let's move on and discuss why do we need autoscaling now. So you learned how to create an AMI. Let's go ahead and understand autoscaling and see how they are connected to AMIs. Alright, so say you have an application, you have a website, and every machine, now this website is hosted on some server, guys, right? And servers are nothing but machines. Now every machine has its limitation, right? For example, say this machine is say around 8 GB and say i5 processor. So say it can host around 100 people, right? Only 100 people can come to this website and easily navigate inside the website. But if more than 100 people comes in, this computer or this server becomes slow. All right, so say there are 100 people as of now and they are trying to access your website, and they can easily access it. Now your website becomes a hit overnight. All right, and now a lot of people are trying to access your website, which makes your server overburdened. Now, in this scenario, you can do only one thing, that is deploy more servers and distribute the traffic equally among those servers so that the requests can be handled. All right. Now, this thing is a manual task, and manual is a big no in the IT world, guys. So we invented a service called autoscaling, and using autoscaling, what happens is it actually analyzes the kind of load which is coming in, right? And it deploys the servers according to that. So say around 300 people are coming in, and it sees that you need 3 servers to handle those kind of requests. It will do that automatically. Right, and that is where your AMI comes in, guys, because the new servers that you'll be launching, those new servers have to be taken out of some template, right? So the first server has to be the exact copy of the the second server has to be the exact copy of server 1. The third server as well has to be the exact copy of server 1, right? And that is where the AMI comes in. So what basically happens is, in the autoscaling service, you basically attach your AMI which you created, and using that AMI, it deploys more servers, right? This is why AMI is significant, or this is how AMI is related to autoscaling, and this is why do we need autoscaling. Let's move ahead and just give us a definition that what autoscaling exactly is. So like I said, whenever your load increases and you have to scale automatically up and down, you use autoscaling. So it's not only about scaling up, that is when your load increases, say 3 or 4 servers you have deployed, and when your load decreases, still 4 servers are there to sitting idle, right? So that is not the case. With autoscaling, you can also scale down as per your needs. You can configure everything which you can imagine about scaling up and scaling down in the autoscaling properties. Right? So this is why we need auto scaling. Now, one more thing that you need with auto scaling is, if you would have noticed, I said the number of servers that gets deployed in the auto scaling. Say there are 4 servers which get deployed during auto scaling. Right? Now the traffic has to be distributed equally. Right? So this traffic which has to be distributed has nothing to do with auto scaling. It has to be done by a separate entity, and that is what we are going to discuss in the next section. But before that, let me show you how you can configure the auto scaling properties and attach the related AMI so that the related servers are launched. All right, so let me go to my AWS console. So here am I, and as you can see, the AMIs have already been created. They are live server 1 and live server 2. Now what I'll be doing is I'll be creating auto scaling groups, or I'll be configuring the auto scaling properties so that these servers can be auto scaled as and when required. Right? So before that, I actually have to create a launch configuration. Now what is a launch configuration? So if you look at the AMI, guys, you have only specified what kind of data should be there in your server. What you have not specified is what kind of machine you should launch every time there's a need. All right, so that is exactly what you do in launch configuration. So you have the data, but you don't have the information about the kind of machine that you want to launch. So that kind of stuff you will be specifying in the launch configuration. So what I'll be doing is I'll click on create launch configuration, and now it'll give me a wizard as same as that of any EC2 server. Right, in the EC2 server, I had to choose an operating system, right? So same, it will give me the wizard, but I don't have to go here. I'll have to go to a separate tab which is called my AMIs. Right, so I'll select my AMIs, and now I'll select the newly created AMI the AMI which I just created, which is say we are creating a launch configuration for our server 1 right now. So I'll select the live server 1. I'll click on select, and now it will ask me the kind of the configuration that I want for my server. Right, so I need a T2.micro because we are doing a demo today. Right, so we don't need much of computing power, so we just have to we'll select T2.micro and we'll name our launch configuration a thing. So let's name it as live server 1. Right, and the IAM role is not required, and I'll click on next. Now it'll ask me for adding the storage, so 8 GB is enough for an Ubuntu machine. I'll go to configure security groups. Right, and in these security groups I just have to add the HTTP rule because I have to connect to all the instances that I'm launching. Right, so I'll select the HTTP rule from here. Right, and I'll click on review. So that is it, guys. Nothing else has to be configured here. All right, and it is asking me to check everything that I've just configured. Everything seems fine. I click on create launch configuration. Now it will ask me for the key pair. Right, so every server which will be launched, it will be associated with the key pair which you'll be specifying here. All right, you can create a new one if you don't have already. I already have a key pair, so let me choose my key pair. So that is Hemant_2, and I acknowledge that I have this key pair, and I'll create the launch configuration. It just takes a second or two to do that, and we are done. Alright, so now we have created a launch configuration. We have specified what kind of machine we want. We have specified what kind of data should go into that machine. Now we'll be creating the auto scaling group in which we'll be specifying in which cases we want to auto scale. Alright, so let's create an auto scaling group now. Alright, so it has automatically picked up the launch configuration that we have just created, that is live server 1. Right, let's name this group as live server 1 group. Right, and what is the initial size that you want in your launch configuration? That is the minimum number of servers that you want, so let it be 1. And remember, guys, this is the most important part. When you are creating a launch configuration, ensure that you're doing it in your default VPC to be on the safe side, because there are a lot of settings that you have to do if you create a VPC on your own, and that becomes a hassle. All right, so if you accidentally delete your default VPC, which I did, right, so you have to contact the AWS support team and they'll help you out with it. they'll basically create one for you. You cannot create one on your own. All right. So always ensure that you are in your default VPC whenever you're creating your auto scaling group. All right. So now I'll be specifying the subnets. So basically, you have to select a minimum number of 2 subnets. Right. I'll be not getting into what are subnets, because then it'll be like a 3-hour session. We'll click on configure scaling properties. Now over here you can specify the properties that I was talking about, the when do you want your server to scale, right? So over here you can specify the average CPU utilization. Now what do you mean by average CPU utilization? So there are 4 servers running as of now, right? So it takes the average of all the 4 servers, right? And if the average goes beyond whatever number you have specified here, say I specified 70 over here, right? So in that case, whenever the average CPU utilization will go beyond 70, it will launch one more server. Similarly, if it goes, I can configure one more property here which says if it goes below 20%, like scale down from one server. All right. So if there are 5 servers and the and CPU utilization has gone less than 20%, it'll scale down from one server and come down to 4 servers. All right. And you can also set how many seconds should it wait. Say the traffic is spiking down and up like too frequently, right? So for that, what you can do is you can set a time. So if the 20% mark has been not crossed till say like 5 minutes, then it will scale down a server. Or if the 70% mark of the CPU utilization has been crossed over 5 minutes, it will then only scale up. It will not scale up if at only once for only 1 second it becomes 71%. All right, so you can specify all of that over here, but since I cannot load test my instance over here, I'll just keep it at its initial size, which just means that it'll, even if I delete my instance, that is one instance has to be there in any case. If I delete the instance, it will automatically launch it again. All right, so we'll select the keep this group at its initial size, and we'll go to configure notifications. So I don't want to configure the notifications, neither the tags. I'll click on review and I'll click on create auto scaling group. All right, so I've successfully created an auto scaling group for my live server 1. All right, similarly I'll do the same steps for my server 2 as well. I'll click on create auto scaling group and I'll select a launch configuration which was there for my server 2. So I've not done that, so let's create a launch configuration first for our server 2. We'll go to AMIs and we'll select the server 2 part here. Alright, so I've selected server 2. I'll do the same steps that I did earlier, right? So let me give it the name as live server 2 group. I'll click on add storage, configure security group. Over here I'll add the HTTP rule, click on review and launch configuration, select the key pair, acknowledge it, create launch configuration. I'm doing the same steps, Skype. I'm not doing any new thing here. I've created the launch configuration. Now I'll create the auto scaling group, which is live server 2 group, right? And then the VPC, as I said, should be default subnets, a minimum of 2 subnets you should select. I'll click on scaling properties. I'll keep it at initial size, configure, review, and create the auto scaling group. All right, nothing much, guys. So same things that I did for my server 1, I've done for my server 2 as well. All right, so since I've created an auto scaling group, if you go to your EC2 dashboard, you would notice that 2 more servers are now being deployed. All right, so you can actually identify them over here. See, these 2 servers are being initialized. So these have just been created by your auto scaling group, because we've specified that a minimum number of 1 server should be there at all times, right? Now if you try to go to the IP address of this server, right, you will see that it will have the exact same settings for my EC2 instance. So this is my server 1, right? So as you can see, a new instance got created, but with the exact same settings. I didn't have to do anything. It automatically created an instance with the same settings. All right, and same is the case with server 2 as well, guys. If I go to my server 2 and try to access it, I'll see the same things over there as well. So I'll show you in a bit. Yeah, so this is my server 2. All right, so my autoscaling group is functioning fine. So let us come back to our slide now. So we are done with autoscaling. Now, like I said, you need to have an entity which will equally divide the traffic between the servers that you've just deployed. All right. So they say I've created two autoscaling groups, guys, as of now, right? And why I've created a second autoscaling group, I will tell you in a bit. But for now, understand that there is an autoscaling group. All right. And inside that autoscaling group, say there are 5 servers. And if a person is coming in, or a customer who has logged on to your website is coming in, how would his traffic be treated? How would he know which server to go to, right? So there comes in the third entity, which is called the load balancer. So what load balancer does is, a load balancer, your customer will basically be coming to your load balancer, and the load balancer will decide based on the usage of your servers that which server is more free, and then will give the connection to that server. All right, so this is basically the role of a load balancer. So like I said, a load balancer is a device that acts as a proxy and distributes network or application across a number of servers. Now, I've been saying it repeatedly that your servers are actually your traffic is actually distributed equally among the servers, right? But in a few moments, I'll tell you that there is one more way of distributing your traffic. All right, so before that, let me again stress on the point that this was your auto scaling group, guys. This is just the example that I took in the beginning, right? So there are like these set of users, and they're trying to access your website, and they are being routed to these servers. So this routing is actually done by a load balancer. All right, now, like I said, the traffic which is distributed, it is distributed in two types, right? The first type would be to equally distribute them among the number of servers. Like say there are 5 servers, so it will distribute it among the 5 servers. But if there are there are two kind of servers now, so your load balancer can identify what kind of request is being made by your user. For example, in your website or in your application, you have a part wherein you can process the image, right? And you have a part where you have your blogging section. All right, so if you want to process the image, you want your traffic to go to a different set of servers which are auto scaled at their own in their own auto scaling group. All right, and if you have the blogging section, you have a different auto scaling group which is auto scaled at a different with a different auto scaling group, but you want everything to go from one single link. So the way to do that is using an application load balancer. So let me just repeat what I just said. So say this set of servers, they host your image processing part. They do all your image processing, and these set of servers, they host your blogs that you have on your application. All right. A user comes in, he just logs on to your website, and he goes to a URL which says, say, edureka.co/image. All right. If he goes to /image, your load balancer will see, okay, he's asking for the image kind of content, so he should go to this set of servers, because these servers serve the image purpose. And if you go to edureka.co/blog, your load balancer will identify, okay, this user, he is asking for the blog content, so he should go to this set of servers. All right, so all of that is done using your load balancer. If you compare it with the classic load balancer, it does not have that kind of intelligence, right? What it will do is basically all the traffic that it has got incoming to it, it will equally distribute it among the number of servers that are under it. All right, but with application load balancer, you have this option wherein you can divide the traffic according to the needs of the customers. All right. Now, when you have divided the traffic, again, the same thing will happen here as happens in classic load balancer, that at this point, it will equally distribute the traffic among the number of image servers, right? And similarly, the people who want to access the blog, it will equally distribute the traffic among the number of people who want to access the blog server. All right. So this is what an application load balancer is all about. So classic load balancer was something which was invented earlier, and these days nobody uses the classic load balancer anymore. People are using application load balancer. All right, and that is what our demonstration is going to be all about today. All right, so enough of talks. Let's move on to the hands-on, that is the demo part. So let me quickly show you what we are going to accomplish today. So basically, a user will come in, he will have the address of your load balancer, and if he asks for the image path, or say server 1 in our case, he will go to the auto scaling group of server 1. If he asks for server 2, he will go to server 2, but all of them will have the same address, that is using your address of your load balancer. All right, so this is what we are going to accomplish today. Now, for those of you who didn't understand that why did we create two auto scaling groups, is because we want these servers, that is the image processing servers, to be scaled as well, and at the same time we want the blog servers to scale as well. All right, so that is the reason we want we created two auto scaling groups. So I created a server 1, which you can imagine is for your image processing, and I created an auto scaling group for server 2, which you can imagine is for your blogging section. All right, having said that, guys, now let's move on to my AWS console and go to our load balancers. All right, so what I'll be doing now is I'll be creating a new load balancer, and that load balancer would be of the type application load balancer. So as you can see, I have two options here. Either I can create a classic load balancer, or I can create an application load balancer. So I'll go on with the application load balancer, and I will name it as live load balancer, and the scheme is internet facing. So since mine is a website that I want you guys to access, right, so it could be internet facing. Otherwise, if you are working in a company and that company wants a load balancer for their internal websites that the companies have, you can actually opt for an internal load balancer as well. But since ours, we have a website and we want that to be used, we will use the internet facing load balancer. All right, and the listeners, it's HTTP, that's fine. And the availability zones, like I said, you have to select a minimum of 2 availability zones, and you'll click on configure security settings. All right, so now you'll be specifying the security group. Right, so in security group, it's better to create a new security group. Remember, guys, don't include the default security group for your load balancer. It's a good practice to always create a new security group so that you can customize your rules according to your needs. All right, so I'll create a new security group and specify the HTTP rule, and I'll click on next. And now comes the part wherein we'll be specifying the targets. All right, now what are targets? Now in application load balancer, guys, targets are basically but auto scaling groups. All right, so target 1 would be your auto scaling group 1, your target 2 would be auto scaling group 2, target 3, target 4. You can have as many targets as you want, but in this wizard you have to specify a minimum number 1. Right, so we'll create a new target group. We'll call it as say auto scaling live auto 1. All right, and the protocol is HTTP, port is 80. We'll click on next, and I'll review everything. I think everything is fine, and I'll create this load balancer. All right, so we have not done all the settings, guys. I'll show you how to do all the settings. For now, we have just created a plain load balancer. All right, so I have created a load balancer which is pointing to a target group 1, and that target group is not pointing to my auto scaling group as of now. All right, we will do that now in this part. So we have created, I just created a target group called live auto 1. I'll create one more target group which will be called live auto 2 for my second auto scaling group. All right, so I'll create this, and done. So I now have two target groups, that is live auto 1 and live auto 2. Now these two target groups have to point to my auto scaling groups respectively. Alright, now the way to do that, you cannot point them here, you have to go to your auto scaling groups, right? And in your auto scaling groups, you have to select the auto scaling group that you have just launched. So it is live server 1 group and live server 2 group. So I'll go to live server 1 group, I'll go to details, and over here you'll click on edit. Alright, and inside edit you have this option for target groups. You don't have to specify anything in the load balancers. This option is only for classic load balancer, but we are creating an application load balancer, right? So we'll be specifying everything in the target groups. So for live server 1 group, we'll be specifying the demo server 1. So demo server 1 has already been um, it will be live auto 1, the target group that I just created, and live auto 1 is connected to your load balancer. So basically your load balancer will point to your target group, and your target group is now pointing to your auto scaling group 1, which are pointing to your instances. All right, so this is how it the visibility comes in. So I'll save it. The target group 1 is live server 1 group, and the target group 2 I'll be specifying in the second auto scaling group, which is here, that is live auto 2. Alright, I'll save it, and let me quickly verify if I've done everything right. So this is live server 1 group, and this is live auto 1, fine. This is live server 2 group, and it is live auto 2, fine. So my load balancer can now see the auto scaling groups that I've just configured. So let me quickly go to my load balancer. Now comes the part, guys, wherein I'll be specifying when to go to auto scaling group 1 and when to go to auto scaling group 2. Like I said, we'll be specifying it using the kind of request that the user has made, right? So the way to do that is is by first selecting your load balancer and going to listeners. So once you go to listeners, guys, you will reach this particular page. Now in this you have to click on view or edit rules. Right, so once you click on view or edit rules, you will reach this page, which is kind of an if-else, if-else structured. So now what will you do is, so you can see that there's a default rule as of now, that any request which is made, it will go to live auto 1. All right, which means any request which is made, it will straight away pointed to the auto scaling group 1. Now we'll specify if the request if the user is asking for server 2, he should be pointed to server 2. So let us do that. The way we'll do it is like this. We'll click on add rules, we'll click on insert rule, and now I'll specify. So you have two options here. Either it could be the routing could be based on your host, that is the address of your website, or it could be based on the path. Now what is the difference? Say edureka.co, this is a host name, right? Now if I type in resources.edureka.co, it'll still point to my domain, but if I've specified resources.edureka.co, and if I write it over here and I specify it has to go to server 2, it'll go to server 2. Otherwise, if you type in resources.edureka.co, nothing will happen because you've not configured anything, right? So that is the host path. With paths, the difference is that say you write edureka.co/blog, all right? So that /blog becomes the path. But with host, the thing is, the difference is resources.edureka.co. So that becomes one host name, right? But with path, you are basically putting a slash and you are going into a particular folder. All right, so you can specify the path here. All right, it doesn't matter if you have not specified in your server for different you could the way you could have done the image processing and blog the other way around, rather than having it on two servers, was that you could have configured it inside two servers in your root directory. right? It could be server 1 for your image processing and server 2 for your blogs. But I don't want that, because your as distributed as your system is, it becomes more reliable, right? And that is the reason we have two different servers for two different set of things. So the way you can route your traffic to both these servers is by typing in the path. So say if I have to go to server 1, I'll type in server 1 slash star. So star basically means anything after server 1 can be accepted, but it has to go to, the request will be forwarded to live auto 1. Alright, so if I have server 1 in my path, anywhere in my path, it will go to live auto 1. So I'll save this rule. Similarly, I say that if it has server 2 in its path and anything after that, it has to go to live auto 2. Alright, I'll save it. And that is it, guys. Now my load balancer has saved its settings. Let's hope for the best and try executing it. So this is the link, guys, right? If you just type in this link, it will by default go to server 1, right? So if I go to this link, you can see it is going to server 1 as of now. But if I specify slash server 1, it will go to my server 1. And if I specify slash server 2, it will go to my second server. Now you might be wondering that Hemant, you might have a different directory in your same server. So let me clear your doubt according to that. So what I'll do is I will go to my EC2 dashboard, right? And I'll go to server 1 and I'll quickly show you if what happens if I type in server 2 here. All right. So this is the IP address, right? So if I type in this IP address, I'm going to server 1. If I type in slash server 2, it will give me a 404 because there is no folder called server 2, right? Same is the case here. So if I go to this IP address, you can see server 1. If I don't specify anything after my address, it will still go to the same server that is here, that is this IP address, right? But if I specify slash server 2 over here, it will not be able to do so because this is not a load balancer, it is directly your IP address. But over here, if I specify server 2, it will redirect me to the second server. 1 second. Right, it will redirect me to the second server. And that is all that I need. Alright, so with one address, you are actually pointing to two servers, which will be solving your two problems. Now the real life use case, like I told you, it could be for different kind of tasks. Say you have a blogging section on your website and you have an image processing section on your website. If you want two different servers to host your two different services, you can do that easily using a load balancer. Alright guys, so with this I conclude my